Imagine a building that breathes, filters its own air, and adapts to its environment, just like a living organism. No air conditioning, no constant maintenance, just intelligent design inspired by the natural world. This isn't science fiction. It's the frontier of architecture known as biomimicry. For billions of years, nature has solved complex problems with elegant efficiency, from termite mounds that maintain constant internal temperatures to lotus leaves that repel dirt and water. Today, architects and engineers are studying these natural systems to create buildings that are not only sustainable, but actively regenerative. Biomimicry, at its core, is about copying nature's genius to solve human challenges. Take the Eastgate Center in Harare, Zimbabwe, for example. Designed by architect Mick Pierce, this building mimics the ventilation system of termite mounds. Termites naturally regulate temperature in their nests, keeping them cool in the day and warm at night without any external energy input. Pierce applied the same principles to the Eastgate Center, drastically reducing the need for conventional heating and cooling, saving the building's significant energy costs and demonstrating the potential of nature-inspired design in urban environments. But it doesn't stop at ventilation. Buildings today are beginning to breathe and grow through innovative materials and systems inspired directly by life itself. Mycelium bricks, made from fungal networks, can be grown rather than manufactured, offering biodegradable, fire-resistant, and insulating materials. Self-healing concrete, another breakthrough, contains bacteria that activate when cracks appear, repairing structural damage autonomously. Even facades are evolving. Lotus-inspired self-cleaning surfaces reduce maintenance, while vertical farms integrated into building exteriors mimic forest ecosystems, purifying air and producing food simultaneously. Biomimicry also allows architects to optimize the basic functions of buildings using natural strategies honed over millennia. Passive design techniques drawn from natural forms, like orienting windows for optimal sunlight, designing airflow channels to enhance natural ventilation, or creating water catchment systems inspired by desert plants, reduce energy use while improving comfort. These systems don't just save resources, they create buildings that interact with their environment in a more harmonious way, blurring the line between the built and natural world. The benefits of bio-inspired architecture extend beyond efficiency. Research in biophilic design shows that humans are hardwired to respond positively to natural environments. Buildings that incorporate natural patterns, greenery, and dynamic, lifelike systems can reduce stress, improve cognitive performance, and enhance overall well-being. Imagine offices where daylight cycles and airflow mimic the rhythms of the natural world, or schools where walls respond to temperature changes like living tissues. These structures don't just sustain life, they enhance it. Future cities could take this a step further, evolving into urban forests where buildings function as integrated ecosystems. Picture skyscrapers with vertical farms along their facades, streets lit with bioluminescent pathways, and AI-driven sensors that allow structures to respond dynamically to weather, air quality, and human activity. These cities wouldn't just minimize harm, they could actively restore ecological balance while creating resilient communities capable of adapting to climate change and environmental stressors. However, transitioning from concept to reality is not without challenges. The upfront cost of experimental materials, strict regulatory environments, and public skepticism can slow adoption. Yet, research continues at an unprecedented pace. Scientists are exploring DNA-inspired construction techniques, self-replicating materials, and other innovations that could one day allow buildings to literally grow from the ground up. These breakthroughs promise a new era of architecture, where buildings are no longer static objects, but dynamic participants in the environment. As we move forward, the question isn't whether we can mimic nature in our cities, it's whether we will. Biomimicry invites us to rethink how we design, build, and live, encouraging a shift towards systems that are self-sustaining, responsive, and regenerative. The future of architecture doesn't just lie in stronger materials or smarter machines. It lies in learning from the ultimate engineer, nature itself. By embracing these lessons, we can create a built environment that doesn't just occupy space, but thrives in harmony with the planet.